Hi, alright, this will be a second examples of using Newton-Raphson method to finding a roots of an equation in a specific interval. Alright, so which comes usually we using this method when we have no other methods which we cannot use a normal method such as a cubic factorizations. Alright, because it's never produced an integers or rational numbers, which is very hard for us to really apply the concept of polynomial. So, alright, for like example, these cases here. So we want to show that the equation equals to 0 has a root between these two, right? So it means that there is a root, the value of x that satisfies this equation. What is meant by satisfied? It means the value of x, when you substitute inside here, you are getting equals to 0. You are getting equals to 0. But because of we saying that using Newton-Raphson method, so we actually get an approximation of the roots, right? The roots. The roots may be nearly same as the actual roots, right? So now, okay, the first thing is how to show that the equation has a root between 1 and 2. So very simple. So we just letting fx, because we're going to find fx equals to 0, right? This whole thing is your fx equals 0. You want to find the value of x such that the fx is 0. So which is x cubed plus x minus 6. So you're just showing that the change of sign, for example, f1, right? f1. And you're finding the value of 2. Right, f2. So you can substitute f1 into the equation. You have 1, 3 plus 1 minus 6, which is negative 4. Right? So you substitute the 2 here, you're getting 8 plus with 2 minus 6. So you're getting 4, which is positive value, and the other one is negative value here. So if student asking me why sir telling me that once they have changing of sign means that there is a root between this equation. So very simple. Do you know what is roots? Roots is usually for a function is the x-intercept, right? So this is where the place the value of x and the fx is 0, right? The value of fx is 0 here, right? Means the value of y here, roots. So means that this will be 0, right? Your fx will be equals to 0. Fx equals to 0 when for this value of x. So this x is the roots of the equation. So it means that within this interval, if there is a root, let's say for these cases here, you have 1 here, right? You have 1 here, and you have 2 here. So why is it so special? Because maybe during 1, you see, the value is negative 4, right? During 1, this will be your, because during the value of x equals to 1, you substitute here, you're getting the value of y. The value of y is negative 4, which is below the x-axis, the negative 4, right? So it means after they passing through the roots, means they're passing through these roots. So 2, let's say you substitute 2. You substitute 2, you're getting 4. Means that during 2, the coordinate here is 2, 4. And this is negative 1, negative 4. Can you see? There is a change of sign, right? From negative become positive. Negative become positive. This shows what? The graph is intersecting the x-axis before it's come to 2, right? Before they come to the value of 4. Means that from negative 4 become 4. Suddenly from negative become positive. Means that the graph is actually intersecting the x-axis. So it means that there is a root between these two because of the change sign here. This is the concept, alright? So don't be overthinking. So we just see there is a change of sign, means there is the answer for this equation, right? Alright, so this has already shown you that there is a root, right? You're just making a statement, fx, since the sign change, or you said the signs of f1 and f2 are different. I'm just making a statement. Are different. Therefore, x cubed plus x minus 6 equals to 0 has a root, right? Has a root. This is a verification. We need to verify first, right? So that we know where's the roots. So between x equals to 1 and x equals to 2, right? The first thing that a mathematician should do will be, if you want to finding the roots between this, for this equation, we have to identify the change of sign. So here they have give you the idea, between 1 and 2, there is a change of sign, alright? So very sure there is a root within these two here, alright? So then only we can apply the Newton-Raphson method to find that particular root, alright? The root can be 1.1, 1.9, 1.8, so many, right? There are so many values in between here, right? So to be particular, what is the root? We must using Newton-Raphson method. Alright, let's see. Alright, okay, let's look at this question here. By using the Newton-Raphson with initial approximation of 1.8, right? They just use that, right? Actually, you can using any value within these two, right? You can using 1.1, you can using 1.9, you can using 1.5, okay? But the question have such request that you must use the initial approximation of 1.8. But for your information, you can use any value between these two, alright? Even 1 or 2 also okay, but it's not encouraged to outside the range, alright? So you will be actually using any value of initial approximation within these two, you are still getting the roots, alright? But question have request you using x1 to be 1.8, right? So as we know that the formula for Newton-Raphson method will be xn minus fxn over with f prime xn. You have to remember this formula. It's a very powerful formula generated by Newton and Raphson. So, alright, so how to carry out this? Very simple. So first you need your fx. Your fx in this case will be your x cubed plus x minus 6. And you need the differentiate of this equation, which will be the first derivative of this equation, which will be 3x to the power of 2, differentiate, plus 1. From here, we generate the iteration formula, particularly for this equation. So, which is xn minus with fxn, which is your x cubed plus x minus 6, f prime x, so will be x squared plus 1. So we just denote it with n. So this is the iteration formula that we're going to use to getting the actual roots of this equation here. So first, by applying x1 equals to 1.8 to getting the value of x2, means that I'm going to finding the value of x2, the second approximation, which is better. So I substitute x2, here will be x1. So I substitute 1.8 minus with 1.8 to the power of 3, 1.8 minus 6 over with 3 times 1.8 to the power of 2 plus 1. So then I will getting the value for x2, the second approximation. Alright, so then after I getting the second approximation, I will getting the third approximation. Right, after that I getting my fourth approximation until the value here remain constant. After you round off to 4 decimal places, the value is a constant, then that will be your roots for this equation in this interval. Alright, okay, let's see. I will show you by using calculator in helping me to getting all those values. Alright, okay, let's continue by solving. First, I just want to list all the value here. Alright, later I will show you why I'm getting all this value here. So first, using this calculator. Okay, this calculator is very powerful. Alright, let's look at this. I'm going to key in this. As you know that the first approximation will be 1.8, and another information will be you need the roots correct to 4 decimal places, right? So usually in my iteration, I will give 6 decimal places with extra 2 decimal places to make sure the accuracy, right? Accurate, the value is accurate. So now, okay, let's look at this. So I will just key in this this right hand side, okay, this expression to find the value, right? So I just key in okay, I show you one more time. Alphabet, alright, can you see there is x here? Alphabet x, right? Minus this one, the fraction. So x cubed plus x minus 6. Alphabet x shift cube, right, plus with alphabet x, right, alphabet x, okay, minus 6, and pressing this, going down, and you have 3x squared plus 1, 3 alphabet x squared plus 1. Okay, so you don't care about the n here. This is just a subscript n. Okay, to denote if this is 1, this is 2. If this is 3, this will be 4. Means that when you're finding, if you have the value of x2, you can find the value of x3. Okay, that's just the meaning here. So now I have x1, right? So I can find the value of x2. So by pressing the button CLC, calculate. Okay, calculate the value that you want. You 1.8, right? So you just key in 1.8, right? So pressing double equal 1 time, 2 time. So you get fraction, you can pressing this, you are getting 1.64. So because of they need 4 decimal places, we're giving extra 2 decimal places. So we have 6 decimal places here. So which will be record 1.647761, right? 1.647761. Alright, 6 decimal places here. If you see 1.8 from here, it's very big difference, right? So we have to continue to finding the x3 until the value here remain constant. So now I want to using this value x2 to getting x3. So very simple, don't disturb everything, just key in, because I want to use back this value, right? So I just key in calculate, then I pressing the button answer, right? Then I pressing double equal 1 time, 2 time. Then I getting 1.634462. 1.634462. If you round off the value here to 4 decimal places here, this one is 1.6478, right? And this is 1.6344, which is difference, right? So we continue in finding for x4. Okay, finding for x4. So again, repeat. Don't disturb, don't pressing any, just pressing calculate, answer, double equal. Right, calculate answer, then 1 time, 2 time. So I have 1.63, 4365, 4365. Right, but if you round off this, if you round off the value, means that we look at the value here, you round off, you will become 4 decimal places, which will be give you 1.6345 if you round off, right? 45 is 1.634444, which is still the difference. 45 and 44 is still different, so we continue for x5. We can continue for x5. So now we calculate, repeat the same step, answer, right? Then we're pressing double equal 1, 2. So we have 1 point. Okay, we record the value. This is my x5. So 1.634365. Right? If you look at this, it's already constant, right? If you round off, this is exactly the same. If you round off, you are getting 1.6344, right? This is also 1.6344. So we have to stop here. Okay. After we stop this value, after we round off, which is 1.6344, will become the roots for the equation x cubed plus x minus 6 equals to 0 at the interval for 1 and 2, right? 1 and 2. So if you're trying, you can going for further to finding the x6, this is x5, calculate answer, double equal, you are still getting the same answer. You calculate answer, double equal, you are still getting the same answer. It will remain constant. So it means this is already reached the roots of the equation here, right? So by right, we have recorded the roots will be 1.6344. right? Okay, let's show how to writing your step in the solution. Alright, okay, let's continue. Now we can find the value of x2, which is just now I have listed here, right? So I don't need to calculator go and key 1.8 minus 1.8 power of 3, right? We use technology in helping us. So it will be 1.647761, right? You see, from 1.8, you have iterate and getting the value of 1.647761. So we have to get the value of x3. So very simple, to get value of x3, I have to substitute x2 here, right? x2 is here, so it becomes 1.64. You have to write it down to show that you are actually doing 1.647761 to the power of 3. Okay, I know you are tired, but this is the way we learn maths, right? Discipline. Okay, 1.647761 to the power of 2 plus 1. But we know the answer, right? We know the answer. We know the answer will be my x3, so which I already record by using calculator, which is 1.634462. 1.634462. But you have seen that this is not constant yet. After you round off, you're getting 1.6478. But this one 1.6344 is different, right? So we continue for x4. But I just showing the first two iteration, that's how I substitute. But the rest I just listing down the value here, right? So I will getting 1.634365, right? My fourth approximation, and I might get. Why I continue? Because I see these two, when you round off to 4 decimal places, is 1.6345. This is 1.6344. It's still different, right? A small difference. So we still continue for x5, which will be 634365. After I see this 2 is already constant, if you round off, you are getting 1.6344. Means they repeat, right? Once they repeat, I immediately stop and I conclude that x equals to, therefore x equals to 1.6344 is the roots of this equation at this interval here, right? So means that we firstly suspected. The first approximation means we suspect the answer is 1.8, but actually after apply iteration method for Newton-Raphson, so we have actually can see the actual roots, which is 1.6344. Alright, that's the power of full method introduced by Newton and Raphson. Alright, that's all for this video. Hope you understand.